too, and nobody. Hello, everybody, and welcome to yet another one in the seemingly endless series of Jina's Engineering All Hands. We hold these events once a month where we get together with like-minded tech heads and listen to a presentation by someone who knows what they're talking about. So I'm Alex CG, Senior Open Source Evangelist here at Jina. And hey, thanks for coming, everybody. It's good to have you all here. So we run several events every month here at Jina. This one is the Engineering All Hands. We also run office hours. So if you have any burning questions you want to ask about Jina, be it the technology or working at Jina, or where did Zinyo get his awesome profile picture, then that's a place to come. That's a place to ask your questions. And we will be more than happy to answer them, depending on what the content of the question is. So today, we are doing a raffle after the talk. So buy raffle tickets. Sophia will explain how this works after the thing. But you can be in to win some sweet, sweet Jina swag. So we're lucky to have with us today Aladdin, one of our engineers, and Anne Yang. Anne is new to Jina. She's going to be giving us a talk about how to integrate DocArray package with Redis. So if you have any questions, put them in the chat below, or if you're on YouTube, put them in whatever side the question bar is. Am I missing anything, Sophia?
No, all good.
All good. Okay, without further ado, let's welcome Anne to the stage. Take it away, Anne.
Yeah, thanks, Alex. I'm gonna share my screen now. And yeah, can everyone see it? So hi everyone, I'm Anne Yang. I'm a graduate student in nuclear engineering. I'm from Beijing, China, and I'm also a computer science enthusiast. So I joined Jina through the summer open source promotion plan and finished the project of adding Redis storage backend to DocArray. So today I want to share about this new feature, lightning fast vector search with DocArray and Redis. I have 4 parts of contents prepared, which are what's DocArray and what's Redis and why do we combine it with DocArray. The third part is the usage of DocArray with Redis, and the last part is my experience of contributing to Jina AI. You can scan the QR code at the right corner to learn more about DocArray.
Or we'll be putting a link in our text chat for that as well.
So the first part is what is DocArray? First, I want to talk about neural search. Neural search means you can search any kind of data, no matter it's text, images, audio, videos, 3D mesh, or proteins data. You can just search any kind of data. What does it mean, and what's different between neural search and traditional search? Here is a slide. In traditional keyword search, the target results needs to include like more words in your query. Like the example here, the result sentence, Jina is a cloud native neural search, blah, blah, actually includes the word Jina, which is like the only important word in the query sentence. But the process of neural search is that we embed both query text and maybe all the pictures into vectors first. You can do it by probably neural networks or any other deep learning methods, and find the top key nearest neighbors of this vector. So first, you convert this query sentence like a happy potato and all the pictures, no matter it's potatoes or other vegetables, into vectors, and you find nearest neighbors of the vectors by like distance, or you have like you can use different distance metrics. So Jina is the framework to help you with such neural network and cross-modal tasks, so that you can search for images by text queries, or search for videos by images, or search like a movie clip by text description. And DocArray is a library for nested unstructured data, such as text, images, audio, video, 3D mesh, and it's the foundation of Jina framework. DocArray design objectives are that first, it's intuitive for Python users with no new syntax. So if you can Python, you can DocArray. And second, it maximizes local experience with cloud readiness at any time. And third, it represents multimodal data intuitively to develop multi or cross-modal apps. And following, I'm gonna introduce DocArray a little bit from technical aspects. So first, document is the basic data type in DocArray. You can represent any kind of data structures as a document. There are content-related attributes, which are like URI, text, tensor, or blob. And there are also common-side information or metadata related attributes, such as ID, modality, MIME type, offset, location, weight, and you can like store further information by text attributes. The examples are here, like you can create document with text that's hello, or create a document with blob, or a tensor, which is a NumPy array, or document with with many other attributes like URI, MIME type, granularity, adjacency, and text. And you can also create nested document with nested structures, nested structure related attributes such as chunks, matches, granularity, adjacency, and parent ID. For example, chunks means the list of sub-documents of this document. They have granularity +1, but same adjacency. And matches is the list of matched documents of this document. They have adjacency +1, but same granularity. And we have also the description of granularity and adjacency. So how exactly to use a nested document? For example, here, this picture, you create a document for the whole picture. And this picture is actually divided into 20 pieces, and you can store them in the chunks attribute. Chunk is actually also document, which means you can even divide this small chunk into like even smaller pieces, like here. And you can use match attribute to connect related documents. Like here, this corner, you can like these two like documents, or let's say pictures, they have similar contents with probably different colors, so that you can use match to build connection between these two. Okay, so document array, as the name implies, it's a list-like container of document objects. It's simple as the Python list because it implements all list interfaces. And it's as powerful as NumPy and the array and Panda data frame, which let you efficiently access elements and attributes of contained documents, and accelerates data scientists' work on accessing nested elements, evaluating, visualizing, parallel computing, serializing, matching, etc. So it gives you like very powerful tools to use to like structure and use a series of documents. After that, the next part comes to what is Redis and why do we want to add Redis storage backend to DocArray. So Redis is an open source key value store and in-memory database, which which provides lower latency than other storage backend. Besides, it also has a module named Redis Search that supports the following features. First, it supports vector similarity search, which allows to load index and query vectors stored as fields in Redis hashes. It provides two real-time vector indexing algorithms, which are FLAT and HNSW. HNSW is an implementation of efficient and robust approximate nearest neighbor search using hierarchical navigable small word graphs. And this is a very powerful algorithm. And second, Redis has such commands here to do vector similarity search with filter query. And the third feature is that it supports full text search, which provides support of different languages, attributes filtering, fuzzy search, prefix search aggregations, sharding, and many more functions. We did a little benchmark test for the presentation today, and it compares Redis storage backend with memory and Circlite. It's pretty obvious that with DocArray and Redis, we can execute find by vectors and find by conditions super fast. And the complete benchmark test is on the way, and probably you can scan the QR code here to learn more about DocArray and the benchmark we already have. Okay, the next part is the usage of DocArray and Redis storage backend. So the first feature or function you can do with DocArray and Redis is vector search. The examples here, it's that first you create a document array with storage backend as Redis and set up the config. Here I set dimension to 3 and distance to L2 and other columns. Columns here means I want to index price, which is the integer value, and index stock, which is a Boolean type value as well. And then you can extend this document array with many documents. Here we have a document with embedding and tags attributes. And then I have a filter, which is a Python dictionary, and then to do the vector similarity search. So the results here shows embeddings approximate nearest neighbors with price at most 8 and stock value that is true, like the results here. And our filter query is based on the style of MongoDB's query language. You can use tag filters of value comparison, includes equal, not equal, greater than or equal, less than or equal. And filters above can be combined with two logical filter or logical query language, which are and or. And the data type of all the tag filters are, if you want to use equal or not equal, you can use it on string, integer, or Boolean type values. And you can use greater than or equal, less than or equal on integer values. Or I think you can also use it on other Python number values such as float. Okay, so I provide more examples of the filter here. The first one is it's the same as last page, and here the second one means you want to like get a Nike shoes, or you want to find a pair of shoes. Okay. Oh, yes. The second here means you want to find a Nike shoes, and you want it to be either less than $100 or a blue pair of Nike shoes. Here means you want to find a pair of shoes that's either Nike or price less than $100, or you can like have also nested structures of and or logic, which means here you want to find either a Nike shoes or a pair of shoes that's both a blue color and less than $100. Yeah, so you can also update the searching index schema on an existing document array by setting up update schema attribute to true and changing your configuration parameters. The parameters you want to change are probably like vector similarity indexing algorithm. It can be either flat or HNSW. You can also change similar distance metric. It can be one of L2, epi, or cosine. And you can also change the optional parameters for HNSW or for flat. Here is an example, like first you create a document array, set the storage backend to Redis, and set up some config attributes, like you want the distance to be L2, and you do some like extend this document array with documents, or do some other like steps, and then probably you want to get the same document array but set up this schema to true, and with a new distance choice like cosine here, and do another like find steps, and you can see the finding results will be different. And you can also use full text search here. And in order to use full text search, text needs to be indexed using the Boolean flag here, index text, and you have to set it to true. Then probably you add documents with different text contents and pass a string value in the find function. Like here, you create a document array, extend it with different documents with different text, and then you want to find all the documents with token in the text attributes, like here. And text can also be indexed when it's part of text. It's mostly useful in applications where text data can slip into groups. For example, like here, I specify two series of text, which are food and price, and I can retrieve items based on a text search in food group or in price group. Yeah, like the picture here. And the last part is my experience of contributing to Jina during the whole summer. So during this whole summer, 3 months, I think, yeah, I get a really close communication with all the excellent teams and engineers at Jina. And I improve a lot by convincing others to accept my design. Like first, I have to give a whole design of how I planned to add Redis storage backend to DocArray. Like give all the technical skills and convince others to accept my design, and like before I got to coding. And believe it or not, my oral English skill and like presentation skill really have improved a lot. Yeah. So welcome to join Jina AI. I believe you will also learn a lot like I did. Yeah. We have a website, a GitHub link, and community link here. And you can also scan the QR code here to learn more about DocArray or leave your feedback here.
Thank you, Anne. And yes, if you want to join our community, hit up that Slack link and you can talk to us, ask us questions there as well. We've also got Aladdin with us. Do you want to say a few words, Aladdin?
Yes, so I would like to thank Anne for this presentation and also for her contribution to DocArray during the Summer of Code. Mainly, she contributed to our open source project, and she showed like exceptional talent in understanding our project and neural search in general. And we're so happy to have her join Jina AI.
Yeah, I second that. Good to have you here, Anne.
Thanks. Yeah, I'm really glad to join Jina and contribute more. Yeah.
All right, and if you too want to join Jina, you can do it at jobs.jina.ai, I think. If that is wrong, someone please type it in, but I think that's the right address. It's been a long day. All right, do we have any questions? Any questions at all? We can take some from our own engineers if you have them as well. Don't be shy. Yeah, does someone want to introduce a bit more about DocArray and what it can do?
I can do this.
Sure, go for it.
Yes, so DocArray is mainly a library for unstructured data. We try to support multimodal and cross-modal applications, and it offers like a Pythonic API and favors local development, but also your data is optimized to be in transit and to be used in the cloud. And also we try to make DocArray the single entry point for vector databases. So we support Redis, Elasticsearch, QGIant, Weaviate, ANNLite, and hopefully soon Milvus. So yeah, check out our project, and you can use the same interface and same API to access different vector databases.
Thanks, Aladdin. And if you are just getting into the world of neural search, DocArray is a fantastic way to prototype locally. You can build a search system in just a few lines of code. I've done that in a few notebooks. I'm sure we can dig out the links and post them in the chat, including like the basic e-commerce search from a while ago. And you don't really need to know much machine learning to get started with it. It's a really nice little package. What else was I going to say about DocArray? Oh, just use DocArray. It's fantastic.
So maybe we should reply to this question from Jack. So he said, are all the implementations of DocArray operations done in Redis, or are some done in Python? All right, so the design philosophy of DocArray is to fully leverage the features in each vector database. But at the same time, we try to expose unified API for all these databases. So of course, all the work that needs, for example, CRUD or vector search are done in Redis side. And we have to leverage the database for these kind of operations. What happens in DocArray is that we try to enforce this same API, the same semantics, and the Pythonic experience for users, so that using vector databases to build neural search applications and multimodal applications becomes as easy as possible.
And would this affect which operations persist in the database?
So what do you mean by which operations persist in the database?
That's
Can
a
you
good question.
clarify?
I'm just reading what Jack wrote. Jack, can you clarify?
Okay, can I speak or do I type it?
You're already speaking, too late to ask.
Okay, fine. So basically what I mean here is that some of the operations, I assume, are implemented in Python. Some of the operations are implemented in Redis. So does this affect whether or not an operation will persist to the database? Like if I cast a match, it will create a match attribute, right? And so will the document array that's persisted inside the Redis database also have this match attribute? What if I do an append? Because as far as I know, I think the append is in Python. So if you do append, it doesn't save it to the Redis database, and it only saves it once the program has exited. So does this affect which operations persist in the database? Yeah.
Okay, so I think this really is related to the operation that you are trying to do. So in DocArray, if you perform an operation on your document array instance, it will affect that document array instance. And if it is this instance is connected to a database, then obviously the operation will persist in the database. So if you do append or extend, then you'll have these the results persist there. However, in the case of match, the match operation is bound to the query, and therefore it only affects your query. And your query generally is an in-memory document array. It's not, you don't match like the other way around. So the modification, the appending of matches only happens to the in-memory document array that you used. And what happens inside the database is we just retrieve nearest neighbor documents using your query document array and put them inside the query document array. Does this make sense?
Oh, meaning that for that operation, the Redis operations are always read only. Is that what I'm getting?
Yeah, for that matching, it's just read only. But what will be affected is your query document array, which is an in-memory document array.
Okay, is this true for all the operations? So are all the operations such that relative to the Redis database, the queries will always be read only?
So as I said, it really depends on your operation, and we try to clarify this in the documentation. Append, extend, find, all of these, they are related to the document array connected to your storage backend. So what you usually do is define a document array connected to Redis, and you do myda.extend or .append, and this will directly affect your data inside the database.
Okay, thank you.
All right, we've got more questions coming in. One from Zoe. Anne, could you or the team share any more interesting projects done by DocArray and Redis? I guess since the DocArray and Redis integration is really new, maybe DocArray
really
or Redis in this case.
I can reply to this. So so the feature has been rolled recently, and we have an upcoming blog post that showcases some project with DocArray and Redis. So stay tuned for the blog post, and we'll share updates with you.
Nice. And Nico is asking, can DocArray work on 3D data, specifically point clouds?
Yes. We do actually we do actually have methods that offer support for point cloud. You can check our documentation. I will provide this in the chat, and definitely can work on 3D data.
Awesome. All right, any more questions? Keep them coming, people. All right, yeah, and not just 3D meshes, but if there's a deep learning algorithm that can understand a certain kind of data, then DocArray and Jina can basically work with that kind of data. So as Anne was saying in the presentation, this covers the basic stuff like text and image, but also audio and video. You can build search engines, image to image or text to image or protein to video. I don't know how that would work, but hey, if you wanted to bolt them together, you could. Yeah, one of our community members, Giancarlo, a while ago, he and a colleague built a protein search engine using, I think, Jina 2.x. The code is out there on GitHub somewhere. And if you know any molecular biologists or biochemists who can judge whether the results are good or not, get in touch. Giancarlo's on Slack, or you can ping one of us and we'll get the message along, because that sounds like a really cool project, but none of us are qualified enough to say, hey, this works really well. All right.
Actually, we also, if your data is multimodal and complex enough, and you think like these data types are not enough, we also, you can specify a schema for your data using DocArray. We have this multimodal support, and feel free to use it and let us know about your feedback.
All right, we've got a question from Pingren. Will Jina provide an official Node.js client in the future? Anyone have answers on that? I think we are working on we've got a Go and something client.
Yeah, exactly. Currently we have Go and Python. Actually, our API interface is language agnostic. You can expose the Jina application as gRPC or as a REST interface. So any language can support this. Upcoming client support should come soon.
And if anyone wants to build their own Node.js client and send it and make a commit, we'd be very happy. Oh, sorry, Aladdin, go ahead.
Yeah, so currently we don't have like an official Node.js client.
But yeah, Pingren, if you feel like making one, we'll send you some cool swag. All right, another one from Jack. Is the code to persist the DocArrays in the database atomic? Will it corrupt if it stops halfway? Anyone want to take that?
Yeah, so I would say it depends on the database. So atomicity in general is something supported by relational databases where you can lock the database or make a transactional operation. So under the hood, DocArray will use the database operation. And this means that if that operation from the database is atomic, then our persistence is atomic. If it's not atomic, then that really depends on the database.
All right, thank you, Aladdin. And do we have more questions? Okay, I don't see any more questions rolling in. Sophia, whoops. Okay, Peter. DocArray can hold many data types. Does DocArray need more memory with data increasing? Is there any method that persists data on disk?
All right, so I would say this really depends on which storage backend that you are using. If you are using an in-memory storage backend, like without specifying a storage backend at all, then all your data goes in memory. If you are using Redis, and since Redis is an in-memory database, then of course you will need more memory. And for the other databases or other storage backends, then everything that you add to your document array, it will be stored on disk. That being said, this really like memory usage really depends on how you use your data. Of course, you cannot just allocate all data on in memory and then send it to your storage backend, which persists on disk. And you say like, why am I using too much memory? Of course, in this case, you need to properly use and handle memory usage. You can use generators or iterators, and always refer to your document array, which is connected to a storage backend to optimize your memory usage. So yeah, always refer to your storage backend so that all your data is persisted on disk.
Yeah, and we offer a whole range of document stores as storage backends, not just Redis. Other backends are available, and you can check the document store section of our DocArray docs. That's a lot of doc in one sentence. Any more for any more? Keep the questions coming, people. Sophia, how does this raffle? Oh, I've got a question. Yeah, Sophia, how does this raffle work? Are we doing the raffle among everyone here?
Yes.
Are we doing the question among people who've asked questions?
So the rule of the raffle is the following. First of all, we're 25 people in the room right now. I would like to ask each of you to choose a number from 1 to 25 and drop this number in the chat, so all of us know what is your number. Yeah, so like 12, 11, choose a random number that you like. But make sure you choose only one number and stick with this number. Let's say I give you another 30 seconds. Wait, I also need to choose a number.
Be sure that you've got to everyone marked in the chat.
Yeah, looks good. We do not have repetitive. Oh, we have Anushka and Zoe, if I read it correctly. Both of you choose 12. Could someone of you choose another number, please? All right. Okay, cool. So let me share my screen. Oh, okay, good. Yes, thank you. So we are 20. Can you see my screen?
Mm-hmm.
Okay, are you ready to run the? Are you ready to know the winner of our amazing swag winter edition? 1, 2, 3, go. And it's 13. We didn't have 13.
I think you'll find we did.
Alex,
Rigged the game.
would you like to get a swag or?
For me, what a novelty. I've never had any Jina swag before. Spin the wheel again. I
Okay.
forfeit my swag.
Great. Okay, ready? 1, 2, 3. Let's go once more. Okay.
Is
14.
this a random number generator? Someone needs to report a bug in Python. If
Who
it
is
comes up
number
15,
14? Did we have number 14 here? Yes, it's Nico.
Yes, we do.
yay, Nico.
Great. Congratulations,
job.
Nico.
I hope you're still where you are.
So now, Nico, I would strongly recommend you please join our Slack channel. Here's the link for you. And all of the rest, of course, please join our Slack channel so we all keep in touch and you know when our next event and where you can get your next swag as well. So I'm sending you a link on a chat. Please join. And Nico, if you would like to get your swag, please send me a message on Slack. And yeah, send me your details, address, and all of the other information. I will follow up with you in the next couple of minutes.
Yeah,
After
address,
joining our Slack, of
first
course.
pet's name, mother's maiden name, social security number.
Social security number, of course, yeah.
Stuff. Yes, the important things.
All of the important information, please. Okay, that's great. That's it from my side. I hope you all enjoyed our quick raffle. And I hope to see you next time as well for the next raffle.
When's our next event, Sophia?
So our next event will be at the by the end of the month. It will be our office hour. Let me quickly check the date. It will be on 27th of October. So maybe in tomorrow or the day after tomorrow, if you follow us on our meetup, you will see an announcement of our office hour. It's our monthly event that we run purely for our community, where it's an event where you can join us, join our engineering team and ask all of your technical questions and work on your code together with our engineering team. So you can solve all your problems in one evening. Amazing event to join. So I would strongly recommend all of you.
And this time, come in costume. It's nearly Halloween. Let's have some fun with it.
Oh yeah, true.
All right.
Yeah. So for the next office hour, only people with costumes can join the event.
And like, we mean real costumes. We're not talking crappy Zoom effects, people. We want some effort. The best costume will get the prize. No raffle.
Yeah, it would be so much fun.
Cool. All right. That's a wrap. Thanks, everybody.
Yeah.
Thanks, everyone.
See you
Thank
next
you.
time.
Thank you,
Bye-bye.
Em. Bye-bye.
Bye.
Bye-bye.